So if you've written JavaScript in the past 7 or so years, you have probably dealt with promises at some point. They're used by a lot of packages, a lot of browser APIs, but you might not know how they necessarily work under the hood. And that's something I've experienced working with a lot of new engineers who are breaking into the industry. They can use libraries that use promises, but if they have to write a promise themselves, I find they usually overcomplicate it. Promises are really, really simple. And kind of wanted to walk through some really basic examples here for what promises actually do under the hood, how async await works with them, and some of the other methods that aren't as commonly known that you can use with promises. So I have a really basic HTML, and we're going to keep this example as simple as possible. And so let's actually hop into our code here. So again, it's just a basic HTML file, and we're literally just going to write some vanilla JavaScript. We're going to add a script tag here. And we're going to use a browser API for promises, which is fetch. So fetch kind of replaced XML requests, which is how we used to make asynchronous requests. So fetch allows us to put in a URL, and we can specify the type of method we want, either get or delete, post, etc. We're going to keep our example very, very simple. I'm just going to grab a URL here from type of code. So type of code is just a public API you can use for testing things. In this case, we're going to fetch a to-do with the ID of 1. So fetch is a function that returns a promise. So this, by calling this here, we now have a variable that is a promise, and we can chain off of that. So a promise is an object that has a property called then, and then is a function that takes a function. So we're going to pass an anonymous function to our then clause, and that function is going to get the response that we got from the API here passed to it. And we'll just console log our response. I don't really care what the data is. So if we come back here and refresh, we can see in our console here, we get our response back. So pretty straightforward. Fetch is a function, returns an object. That object has a then clause. It also has a catch clause, which will get an error passed to it if an error is thrown. So let's do console error. And then let's put in just some like gibberish URL here. And if I refresh here, we'll see our error get logged here. The browser will bubble up an error anyway, but then our own index HTML line 11 here will also get logged. And then there's one other thing, which is finally, and finally, I don't believe takes an argument. Finally is just a function that gets called regardless of whether a promise is successful or not. So console log, we are finally done. And if I hop back here, refresh, we are finally done. If I revert this back to that type of code URL where it was successful, we got the response, and we are finally done. This works similarly to try catch, finally. And if you didn't know, try catch, anything within the try block that throws an error will be caught by this, and then you can have an optional finally block, which again will get called no matter what. So whether the code you wrote is successful or not. So there's a lot going on here. It can be very confusing when you see all these sort of properties chaining off of one another and anonymous functions wrapping other functions. So again, a promise is an object, and we can actually write our own promises here. If we do new promise, right? Just like we're creating an instance of a class, promise is a class, and this is the constructor of the class, right? What we're going to pass to the constructor. And here, we actually pass a function. Promises take functions in. And that function, so functions within functions, that function takes two parameters, resolve and reject. You can call them whatever you want, but that's sort of how they're documented. And resolve and reject are promises, or excuse me, are functions. So resolve will be called if we think our condition is successful. And reject will be what's called if we think our condition is an error, and we're going to bubble that up. So that's an important thing to remember. There's no magic that sort of goes on that tells the code it's an error. It's up to you to specify, no, we hit a reject clause. Let's pass an error to our user, or let's successfully resolve. So let's say we'll just call it const promise equals this, and we will resolve hi there. And let's comment this out for now. And then I can do promise.then. We'll call it answer, and we'll just console log, answer. So we save that. So hi there, again, let me make this a little bit bigger. Hi there was what was passed to resolve. So whatever the promise resolves gets passed to our then clause, or it gets passed specifically to this function, which is our callback function, which is called the then callback, the callback function that we pass to our then property. So in this case, this is actually not asynchronous because, right, we didn't actually wait for a request to go out. This request actually took time because I had to make a request out to that server, wait for a response to come back, and then communicate that to us. And that's sort of the concept of promises. Promises are meant to be used with asynchronous behavior. It's literally saying, when this asynchronous behavior finishes, I promise I will do that. Promises in themselves are not asynchronous. And I think that's a place where people get very confused, is that, again, they think that they're doing a lot more than they should. And really, they're just a tool for you to write callbacks and specify when those callbacks get called. So here, this is not asynchronous, right? We're not actually waiting for a response. This is executed immediately. But how does that work if, let's say, I have another console log, or I just have more code after this? When does this get called? So we had another console log here. We refresh. So you see that console log actually gets called before this one, even though that promise resolved immediately. And the reason is promises will move everything to the next tick or the next cycle of the event loop. So it will technically execute this, even though it's resolving quote unquote immediately. It will execute this after all of this code is finished running, even if this took no time whatsoever to resolve. Even if this request out to the server took, no time, took faster than it took to actually compile and run all this code, it will still get pushed to the end. So that's one thing to sort of keep in mind. Promises will always move to the next event loop. So there's still a lot going on here. And when I talk about callbacks, the then callback, the catch callback, etc., people still think it looks really, really complicated. And I find a really great way to understand how promises work is to sort of just recreate the behavior. So let's create a new file, and we're going to call it swear to God. So it's like promise, it's just like a lot more extreme, right? And remember, we do new promise, right? So that means promise is a class. So we're going to create a class called swear to God. And that takes a constructor method. So remember, we pass a function to our constructor here. So we're just going to call it callback, right? So we'll just set that property on our object, this.callback equals callback. So again, this function does get executed, but it waits till the next tick, the next event loop. And a really easy way to do that is to wrap this in a set timeout with no time. That will force JavaScript to move it to the next tick. I know newer versions of Node have a next ticked function, but let's just assume we don't have that available to us. So we're going to do set timeout. So set timeout is a function that takes a function. Everything takes functions, and we're just going to call the callback. Now we'll write more here in a minute, but for now, this is the basic logic. We're creating a new object. It accepts a function, and that function is going to get called in the next run of our JavaScript event loop. So now we have our instance of our object. So when we had our instance of our promise right here, it returned something that had a then method. So then is a function on our object, and so is catch. And both of these also take callbacks, right? So then is a function, right? It's a function that accepts a function as its parameter, and same with catch. And these will be the things that are called when something is either successful or fails. So we will say this dot then callback equals the callback function that we're passing here. But then we have to make sure that we return the object itself, because that's what allows us to chain. If then didn't return anything, then I couldn't do .catch after that, right? Because then the value returned by then would be nil. But by returning the object, the promise, I can keep chaining this method over and over again. And that's how we can also chain thens, and I'll get into that in just a moment. So, and we'll do the same exact thing here with the catch clause. We'll just call it this dot catch callback. Okay, so these now get two functions assigned to them. But how do we actually call that? Well, that's remember, when I call resolve, that is the way of telling the promise object that this function, the then callback, should be called with whatever I passed as the value here. We'll write what's called a resolver function, and resolver is going to accept the value, and it's going to call this dot then callback value. All right, so it's going to accept the value and pass that value to our then callback. Technically, it's going to pass all arguments, I believe, if you can pass multiple, but we're going to keep our example really simple here. And we're also going to have a rejector function, rejector, and this will call the catch callback. Okay, so remember, promise is an object, takes a function as its constructor. That constructor function takes resolve and reject. Resolve is a function that you can pass literally anything to, and it will forward that on to the then callback, right? So the last thing we need to do then is pass these two things to our callback function, right? Because we're going to write the callback function. We're going to say it accepts two parameters here, resolve and reject. Well, we have to actually grant access to resolve and reject. So we're going to pass this dot resolver, and we're actually going to bind this. So we're going to make sure that resolver is called within the context of this object. You could do an arrow function too, whichever way you want to write it. And this dot rejector dot bind this. Okay, so let's actually bring our little script in. So we'll have our head here, and we'll add a script tag with the source equals, swear to God. So if I go here and I literally just change this to swear to God, right? That's how it's written here. Make sure I'm copying and pasting everything right. This should hopefully work just like it did before. So if I go here and refresh, we see we have the same exact behavior. So I created a new object. I passed a function to it that gets passed to the constructor. Actually, I don't even think I need this line. So that gets passed to the constructor. That function then gets called and passes two properties to it, the resolver and the rejector functions that we have here. And these two functions will take whatever value you give them and will forward them to the appropriate, we'll call them life cycle callback. So if I do, let's say, reject here, we should not see hi there get logged anymore. This dot catch callback is not a function. Oh, because I didn't specify a catch here. Catch error, and then we'll console.error, the error that's passed. So if I refresh now, so we see hi there, and it gets, the browser marks it as an error because I said console.error. So reject will call the function that is passed to catch. Resolve will call the function that is passed to then. So again, hopefully this just demonstrates that promises themselves, again, are not asynchronous. They are just a mechanism for you to write callback functions in a standard way. We just sort of agreed this is the standard, and it works well for asynchronous behavior because we don't know when that stuff's going to resolve, and we'll say, okay, when it does resolve, I promise that then I will do this. So let's actually put that to the test. Let's see if we can use our new swear to God class with something asynchronous. So we can't use just fetch because fetch is a browser API that's already using promises over the hood. So let's write our own fetch method. We'll call it soFetch. So if you're a Mean Girls fan, maybe you'll appreciate that. So we'll just create a function called soFetch, and it will accept the URL just like fetch does. And it's going to return a promise, or it's going to return a swear to God. So that is, again, an object that takes a function, resolve and reject. Our two parameters pass to that function, and we're going to create a new request. And this is how we used to write HTTP requests back in the day before things like fetch were even available. So we'll open the request as a GET request, and we'll pass the URL to it. Now we use event listeners here. So on load, we will resolve request.response. So as it finishes, we will resolve it. If there is an error, that's also a function where we will reject, and we'll throw an error. Oh no. And then we will send the request. So we're creating a request object, and then we're saying when this request object finishes, we'll resolve the response. If there is an error, we'll send the error. Now that we've set up these listeners to the request, we'll send the request out. So let's go back here. Let's import our soFetch. And let's we'll comment this out too, and we'll actually bring this back in. But now we'll call soFetch, and we will save. And when we return new swear to God. Oh, and finally, I didn't actually write the logic for finally. That's what it's complaining about. But now we get the response back. So we don't get a response object. That's something that the fetch API does because it includes things like the status code, headers, etc. Right now, all we're getting back is the JSON that is returned. We literally just invented our own browser APIs from scratch. We wrote swear to God, which is very similar to promises, and we overwrote fetch, which is very similar to fetch. So now you might be wondering, okay, how does this work with async await? So async await, let's say we have an async function called do the thing, right? Let's steal this again. So if we were to switch this back to fetch, we could say const response equals await that, and then console log the response. And then we actually have to call this function, do the thing. Oh, I didn't do a capital T, do the thing. So here we got the same exact response. Remember, that was just part of the then clause. So async await is a much easier way for us to sort of reason with promises. We say await this promise and assign the successful response to this. So how would this work if it was something like soFetch, which again isn't using a real promise, it's using our class swear to God, and it still works. And the reason for that is async await doesn't do anything magical either. Async await literally just looks to see if you have what's called a thenable object. It's literally, do you have an object that has a property called then? If you do, then I know how to await that. So even though we're not using real promises under the hood here for soFetch, it still was able to use await, the await keyword here, on this dummy object, very simple version of a promise. So that is what async await really does under the hood, and it's just a nice way for us to sort of write that. And if you want to catch errors, that's when you have to do a try catch block, because by default we won't have a catch method like we do, but I'm not going to bother writing that out. Most of you know how try catch works. So that's a basic understanding of promises, right? Again, they're just a tool for writing callbacks. But the promise object does a lot more than what we just outlined here. This is, again, a very, very simple example. Let's say one thing I use a lot is when I need to fetch multiple promises and I don't want to await all of them, right? I want to run them concurrently, so to speak. Let's say we do const promise 1 equals, we'll grab this line again, but we'll use fetch for now. And let's just delete you. And we'll do promise 1, promise 2, and promise 3. So let's say I have 3 promises, 3 requests that I need to go out, and they are not dependent on each other. So promise 2 does not need to wait for promise 1 to finish. If I were to use async await, though, and I've seen a lot of people do this, they'll do this await, right, because they're all asynchronous. However, this will literally keep this one, like this line will keep this line from running until it finishes. That's sort of the downside of using await with multiple promises. However, we can put all of these into an array, and we can do Promise.all. So Promise.all is a static method on the promise object that takes an array and runs all of those promises. Responses, we'll say, and we'll console log responses. Oh, console log responses. There we go. So now we have 3 response objects here, and it ran all those promises at the same time. It did not wait for one to finish in order to run the other. The problem with this, though, is that if one of these promises fails, they will all fail. And you don't always want that behavior. Sometimes you do want that behavior. I want to hold everything up if even one of these fails. But if you don't care, you can use what's called all settled. So all settled, much like all, takes an array of promises. However, rather than just returning what those promises resolve to, it returns objects that have the status, whether they were fulfilled or rejected, and then either a value or the reason that it was rejected. And these are things that a normal promise object keeps track of. Const new promise. Yeah, I actually have to pass. So we'll say resolve, reject, and we'll do resolve foo. So I have a variable here. And if I just log foo, it will tell me whether or not it is fulfilled here, because it will show me the promise object. And if it's pending, it'll say pending, like it's still waiting to hear back from the server. And if it's rejected, it will say rejected. So again, promises do a lot more than our simple little swear to God example. It tracks a lot of things internally. It has methods like all and all settled. It also has a method called race, which I find I haven't found a reason to use this yet, but let's say, So race, like all and all settled, takes an array of promises. However, it will return whichever one happens to finish first. So in this case, it looks like to do 3 actually returned first. But if I refresh, it's like to do 1 is now finished first. To do 1. Again, I've never found a practical reason to use this, but I guess if you're requesting the same data from multiple APIs, but sometimes some of them are faster than others, this is why you would use promise.race. And finally, the only other things I ever use on promises are the direct resolve and reject functions. And the reason you would do this is if you have a function, let's say function request data, and it's like if user.settings.has internet, right, then it like fetch whatever, right, and we're going to return that. We're going to return a promise here if you have internet, but if you don't, we're saying there's no point in sending out a request. However, since this function returns a promise, anybody who uses this request data function would do request data dot then. But if I did something like, oh, if I don't have internet, just return null, that'll throw an error because it'll say dot then doesn't exist on null. So you would want to do this promise.resolve internet or promise.reject, right? So we're still going to return a promise. We're just going to instantly reject or instantly resolve. That way it doesn't break any APIs that you've created, and people can safely call .then on the request data function, and it will still treat it as a promise, even though we are instantly just rejecting or resolving. It's a good way for you to write guard clauses around your functions that interact with promises. So I hope that all made sense. Hopefully I didn't go too fast. Again, promises, they're really simple. They just leverage callbacks, and they just give you an easy way to leverage callbacks. They can look really complicated because you can actually chain then methods indefinitely. One error will bubble up all the way to the top catch. But for the most part, it was just a way for developers to have a common tool to use when dealing with asynchronous behavior. Promises in themselves, again, are not asynchronous. So if you have any questions, feel free to leave a comment below. And hopefully you enjoyed that, and let me know if there's any other JavaScript specific things that you want me to dive into.